In class, we did an activity where we used mirrors to estimate the height of an object. That is called indirect measurement, and we can use indirect measurement to help us estimate the heights of many objects. So we're going to take a look at a couple of examples here, and then you'll get some more practice on your own. So here we have a picture where a man looks into a mirror at the flagpole in front of him. Two similar triangles are created. How tall is the flagpole? So this looks very similar to our situation with the mirrors. So the mirrors would be at point X. We have the man 5 feet from the mirror, and the pole is 25 feet away from the mirror as well. So we can write a proportion. So the height of the man and the height of the flagpole would correspond, and we can call this height X. So we can say that 6 corresponds to X, and the distance of the man from the mirror, 5, corresponds to the distance of the pole from the mirror, 25. And we can use that method to solve proportions, that butterfly method. So we have 6 times 25 equals 5 times X. 6 times 25 is going to be 150 equals 5x. Divide both sides by 5, and 150 divided by 5 is 30 feet. So our flagpole is 30 feet tall, which would make sense because 25 is 5 times more than 5, so our flagpole should be 5 times taller than the height of our person. Here we have a flagpole that's casting a shadow that is 50 feet or 600 inches long. At the same time, a woman standing nearby who is 5 feet 4 inches or 64 inches tall casts a shadow that is 40 inches long. How tall is the flagpole? So we have this situation where we don't have any triangles, but we have the height of the woman, we have the height of the flagpole, and we have, actually no, we don't have the height of the flagpole. That's what we're looking for. So we're looking for this value. We know that the woman is 64 inches. We know that her shadow is 40 inches. And we know that the flagpole shadow, let's draw that a little bit better, is 600 inches. So like I said, we don't have any triangles, but we can complete the triangle by drawing from the top of each object to the end of their shadows. And we can identify the corresponding parts of these triangles. The shadows would be corresponding, and the height of the individual to the height of the flagpole would be corresponding. So we can set up a proportion. 40 over 600 would equal 64 over x. So notice my values in my numerator both come from my person, the height and length of the shadow of the person, and the numbers in my denominator are the corresponding values with the flagpole. Now, to help us a little with solving this, I can simplify my 40 over 600, so I don't have to work with such big numbers. I could divide both of them by 10. So if I divide both of these by 10, Actually, I'm going to divide both of them by, yeah, I'll just go by 10 for now. Divide both by 10, and I will have 4 over 60 equals 64 over x. And I can do my butterfly method. So I have 4 times x equal to 60 times 64. Off to the side here, I'm going to multiply 60 times 64. So that's going to be 0 and 24, 0 and 36. So 3,840. So 4x equals 3,840. Divide both sides by 4. And we have x equals, that's going to be 960 inches. We can convert that to feet, since we know how long the shadow of the flagpole is in feet, by taking 960 and dividing it by 12. Well, I know 12 goes into 96 8 times, so 12 would go into 906 80 times. So this would be 80 feet. So obviously our picture isn't drawn to scale here, but we at least have, or actually it is drawn better. I have my numbers mixed up in my head. So we have it in inches and we have it in feet. And the reason I divided by 12 is because there's 12 inches in 1